Hey, hello everyone. I'm Dr. Santosh Chajed. I'm from PhD Pharmaceutical Sciences. In this video, I'm going to discuss nucleophilic substitution reactions. Moving forward, in this video, we will learn about both SN1 and SN2 reactions. So we know that when we allow reaction between alkyl halide and either NaOH or KOH, formation of corresponding alcohol takes place. So basically here, OH, that is a nucleophile, become replaced with a particular halogen present, but we should think why there are two different types of reactions are there as far as the SN1 and SN2 is concerned, because all what involved is alkyl halide gets converted to corresponding alcohol by the action of either NaOH or KOH. So why there is a need to discuss nucleophilic substitution reaction under two different heading, that is SN1 and SN2 reactions. So basically, when we talk about the nucleophilic substitution reactions of alkyl halide, we should first give thought on structures of alkyl halide. So basically, there are three different types of alkyl halides are there. That is primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. So moving forward, in the first case, when you talk about the bromoethane, that is a primary carbon is present, and on the action of either NaOH or KOH, formation of corresponding alcohol takes place. So when you talk about 2-bromopropane, this is a secondary alkyl halide which also reacts with NaOH to form a corresponding alcohol. And lastly, that is 2-bromo-2-methylpropane, it converts to corresponding alcohol by the action of OH. So basically, irrespective of nature of an alkyl halide, when it reacts with OH minus, or rather we could say NaOH or KOH, formation of corresponding alcohol takes place. And what we are discussing is why there is a need to discuss nucleophilic substitution reaction under two different headings, that is SN1 and SN2 reactions. The reason behind this is structure of alkyl halide. So whether it is primary, secondary or tertiary, that will decide course of reaction. So basically product form will be same, that is corresponding alcohol, but how it gets converted, whether it in one step or whether it is in two step, that will decide whether the reaction will be SN1, that is nucleophilic substitution unimolecular, or SN2, that is nucleophilic substitution bimolecular. When you react tertiary alkyl halide, it allows the formation of a carbocation, because we already learned of the fact that tertiary carbocations are more stable as compared to secondary and primary, and because of this stability, so basically tertiary carbocations are more stable over the secondary and secondary are more stable over the primary carbocations. And you could see that the order of stability it is there in front of you. So you could see easily that because of inductive effect of 3 methyl groups, it produces the dispersal of positive charge on the carbocation and that stabilizes the carbocation. So this is the reason that because of plus I effect of alkyl groups present, tertiary carbocations are more stable, and stable the carbocation, faster it will form. And this is what it happens in case of tertiary alkyl halide. So when you take tertiary alkyl halide for the nucleophilic substitution reaction, it takes two different steps. First step involves formation of a carbocation because of a stability, whereas in case of a primary alkyl halide, primary carbocations are not stable, and that's why their formation is not takes place. And when you react primary alkyl halide in the nucleophilic substitution reaction, conversion to corresponding alcohol will occur in a single step. And that's why because of structure, whether it is primary or secondary or tertiary alkyl halide is present, course of reaction, that is number of step vary. It could be a 1 in case of a primary alkyl halide, and it will be 2 step when tertiary alkyl halides are there. And because of these, there are two different reactions are there, that is nucleophilic substitution reaction unimolecular, that is SN1, and nucleophilic substitution reaction bimolecular, that is SN2 reaction. Moving forward, so we will compare preliminary what difference is there between SN1 and SN2. Already made mention, in case of SN1, tertiary alkyl halide will react to form a corresponding alcohol. This will occur in 2 steps, whereas in case of SN2, primary alkyl halide will react to form a corresponding alcohol, and this will occur in 1 step. So this is how, depending upon the structure of alkyl halide, whether it is primary or tertiary, path of reaction will be either SN1 and SN2. We will discuss another important nucleophilic substitution reaction, that is nucleophilic substitution unimolecular reaction, a 2-step reaction where it involves formation of a carbocation. So basically, when you carry out nucleophilic substitution reaction on tertiary alkyl halide, the 2-step mechanism will be there, and the first step involved will be the formation of a carbocation. We already discussed why tertiary alkyl halide allow the formation of a carbocation, how the tertiary carbocations are stable due to inductive effect of 3 alkyl groups present. Moving forward, we will take example of alkaline hydrolysis of a tertiary butyl bromide, that is reaction between tertiary butyl bromide and NaOH. It involves formation of tertiary butyl alcohol. So now when we talk about the rate of reaction or kinetics, SN1 reaction follows the first order kinetics, that is rate of reaction depends upon the concentration of only one reagent, that is rate of reaction depends upon the concentration of tertiary butyl bromide. Now why this happen, even though that both OH minus and tertiary butyl bromide reacts in this reaction, how come rate depends upon the concentration of tertiary butyl bromide? We will discuss during the mechanism in detail. In the equation form, rate is equal to constant K, that is it depends upon the concentration of a tertiary butyl bromide ions only. Now we will see mechanism. We already discussed that the mechanism involves two steps. Step 1, it involves breakdown of carbon-bromine bond to form carbocation and bromide ion. So basically this breakdown of carbon and bromine is a slow process. Slow dissociation of CBr bond occur, and that's why I am highlighting this, because any step which is a slow, that is the rate determining step. This step will determine the rate of overall reaction, and you could see that rate determining step does not involve OH minus ion, and that's why rate of SN1 reaction depends upon concentration of tertiary butyl bromide only and not upon the concentration of hydroxide ion present. Second step involves, once the carbocation form in the first step, this will unstable, rapidly it will combine with the nucleophile OH minus to form corresponding alcohol. And the second step, already made mention, this is a fast step of the mechanism. Now few aspects are there which I would like to highlight as far as the mechanism is concerned. So we already discussed that the rate of reaction is determined the slow breaking of CBr bond to form carbonium ion. That is the first step of the mechanism. Carbonium ion reacts rapidly to form the product, that is the step 2, and I already made mention a single step which will determine the rate of overall reaction will be termed as a rate determining step. Now we will discuss about the stereochemistry of SN1 reaction, and it is said that stereochemistry of SN1 involves the racemization. Racemization is nothing but formation of a racemic mixture. So now we will discuss in detail what is meant by racemization, or term that is racemization has arrived in this case. Now if you recall, the first step of SN1 involved the formation of a carbocation, and the second step involved attack of a nucleophile to carbocation so that a corresponding alcohol will form. When carbocation is formed, nucleophile OH minus will coordinate its electron to the carbocation, and we all know that structure of carbocation is a flat in the nature, it's a planar in the nature, and as a consequence of that, OH minus will be able to share its electron with the carbocation from both the sides. When carbocation is formed, it allows sharing of electron by the nucleophile from both the side of the carbocation, and it results in the formation of isomeric product. Now you could see that there are two isomeric products are formed. One isomer is formed due to inversion of a configuration, whereas other isomer is formed that is because of retention of a configuration. And configuration is nothing but the arrangement of a substituent around the carbon in 3D space, or that is called as the spatial arrangement of the substituent around the carbon. Now both the isomers are formed, they do have, that is whatever product is formed that results due to 50% inversion of a configuration and 50% retention of a configuration. Or how configuration is inverted or how configuration is retained, that answer we will get if we compare the structure of tertiary butyl bromide, which was our starting compound. You could see that position of a bromide ion, it is on the right hand side, and in retained product, that is the isomer which is formed has a retention of a configuration. You could see that in that particular isomer, position of OH is same as that of position of bromide ion which was there in the substrate, and 3-methyl group are on the same side which were there earlier in case of tertiary butyl bromide. Other isomer where we are saying that configuration has become inverted, you could see that OH has taken a position opposite to that of bromide ion which was there earlier. Position of 3-methyl groups is opposite to that of position or orientation of methyl group which is there in case of tertiary butyl bromide, that is the substrate. And that's how inversion of a configuration and retention of a configuration, it is become clear when we compare structures of product, that is alcohol, with the structure of substrate, that is alkyl halide. So in general, SN1 stereochemistry involves racemization, that is the equimolar mixture of two isomeric product is formed, and it is said that SN1 involves racemization. So this is all about the mechanism, stereochemistry and rate of reaction or kinetics of SN1 reaction. Thank you for watching. Thanks for patient listening. And if you want to learn organic chemistry in very simplified manner, do subscribe my channel, share with your friends and press the bell icon for updates. Thank you.